Hi there, it's Mrs. Nelson. We're going to talk today about the main organ of excretion, which is the kidneys. So you've likely heard of the kidneys before. We're going to delve into the inside of the kidney, talking mainly about the nephron. So you might not have heard about that before. So keep in mind that you might have to review these little notes more than once because students often find this unit tricky. So kidneys have three major divisions. So we have the outside, the middle, and the inner cavity. So the renal cortex, and you'll see that renal's in brackets. That word renal I mentioned yesterday means kidney. So you hear renal, that's kidney, it has to do with the kidneys. So the renal cortex is the outermost layer. So on the diagram it says outer layer here, okay? The renal medulla is the middle layer, and it's called, it says striated there. Striated is a fancy word for the word striped. And if you see this little diagram called the nephron in there, you see these things hanging down. That makes it kind of striped. So when you look at it, if we were to get to do our fetal pig dissection in the spring, in June, you would get to see these different layers of the kidney, but you can't see a whole lot else with it. And the renal pelvis is the innermost cavity. So sometimes the medulla means middle. Sometimes it's called the inner layer because it is the inside layer, because this pelvis isn't actually a layer, it's a cavity, it's a space. Often in this unit, you'll just hear these layers referred to as cortex, medulla, and pelvis. Obviously, when we're talking about the pelvis, in this case, we're talking about the inner part of the kidney, or that inner cavity, not kind of the bone structure around your hips. So just keep that differentiation in mind, because we'll often leave off those words renal because we're talking about the kidney, so it's already talking about that. So you have a diagram similar to this in your book. So part A is going to be the renal cortex, part B is the medulla, part C is the nephron, part D is that renal pelvis, that innermost cavity, and E is the ureter or ureter, however you'd like to say it. Now you might have heard of something called kidney stones. So kidney stones can sometimes form in the pelvis here, and I've asked you to draw some on, so you can see in my picture here there's three kind of green dots there that I've drawn on. Kidney stones are calcium salts and uric acid that form and harden inside that inner pelvis. They can pass naturally, apparently it's very painful, or be kind of treated with surgery. And they can be destroyed with sound or light waves, kind of to break them up if they're too big to pass. Primary cause of kidney stones is too much protein in the diet. So once you've had kidney stones, you have to be kind of careful about what you eat. There are things like asparagus or whatever else that has some of that uric acid in it that can contribute to that. But the cause is mainly too much protein in your diet. So if you think about who normally eats more protein than others, men are often more prone to kidney stones just because of the amount of protein that they'll eat. Nephrons are the functional units of the kidney. So functional units mean they're doing all the work. They filter the waste from the blood, they retain or keep water back if we need it, and other needed materials. So there's about 1 million nephrons in each of your kidneys, and urine formation occurs in the nephron. So you have 1 million little nephrons in each of the kidneys doing all the work to get rid of the waste, keep the water, and keep other materials that we need. And then everything else that's waste gets put into our urine. So we'll go into a diagram of what that nephron looks like in a minute, but the nephron has a Bowman's capsule, and sometimes this is called the glomerular capsule, but the Bowman's capsule is like a strainer or sieve. So it's a cup-like end of the nephron where wastes are forced out of the blood and into the nephron. So blood enters through a capillary tuft called the glomerulus. The glomerulus is kind of the blood network, and basically it shoots everything like the end of a hose into this cup called the Bowman's capsule. And anything that's large enough, small enough to fit through will get filtered into the Bowman's capsule. Anything that's too large will stay in the blood. So the afferent arteriole carries blood to the glomerulus. I'm going to ask you to watch a video later today, and the fella's Irish, I think, and he calls it the glomerulus, but glomerulus, however you want to say it, same idea. The efferent arteriole carries blood to that glomerulus. So we've got a blood network coming to the glomerulus, that capillary tuft, and carrying it away. From that capsule, the nephron narrows into the proximal convoluted tubule. And that then goes into the loop of Henle, and that's surrounded by the paratubular capillary network. Okay, so the paratubular capillary network is the blood network that's going to be there to catch all the things that we reabsorb, because we don't want to lose everything that's filtered into that Bowman's capsule. The loop leads to a distal convoluted tubule. The word convoluted, by the way, kind of means twisty. So when we look at the diagram in a minute, the proximal and distal convoluted tubules are going to kind of twist and turn around. And then it enters the collecting duct where all the urine is collected together. So here is a diagram of the nephron. So you do need to know this diagram for a test or a quiz. Okay, so here, I'm going to actually just get a pen here for a second, bear with me for a minute. Here we have our afferent arteriole. It's bringing blood to this capillary tuft called the glomerulus. Anything that's small enough will be kind of pressure filtered, again, like your finger on the end of a hose, into this cup called that Bowman's capsule. Things that are too large, like proteins and blood cells, so white blood cells, red blood cells, that sort of thing, will go via the efferent arteriole, and it'll end up in this capillary network that surrounds this net that surrounds the nephron. So we have, once the things that are small enough get pressure filtered in, so anything that's small enough, so water, sugar, salt, those are all going to be small enough to get filtered into the Bowman's capsule, but obviously we can't lose all the water in our blood, all the sugar in our blood. So our body then reabsorbs it back from these parts of the nephron. So the first kind of area of the nephron past the Bowman's capsule is the proximal convoluted tubule. So this twisty tubule here, and certain things, and we'll talk about that tomorrow, are going to be reabsorbed back there. Then we have this, what we call the loop of Henle. It's going to come down, and its major function is to reabsorb water. Okay, so this loop here. And then we have the distal convoluted tubule, another twisty tubule. It's kind of our last ditch effort to put anything in or take anything out that we want to collect in that collecting duct here. And this collecting duct is going to collect the waste from a whole bunch of different nephrons and take it into that renal pelvis, so it can form urine and go down the ureters for storage in the bladder. So that's the collecting duct. It will reabsorb some water as well. And again, I've labeled the paratubular capillary network, this capillary network that's around the outside, because as we reabsorb stuff back, we want to reabsorb that back into our blood. So this would lead to the renal arteries over here. And then this would collect all that stuff that's freshly filtered in the renal veins and take it back to the heart, this freshly filtered blood. This dotted line here divides the sections of the kidney. So we have the outer cortex and the inner medulla here. And we said the medulla was striped, and it's because we have all these kind of lines that go up and down, these tubes that kind of run in stripes, and that's what makes that area striped. This is, again, a diagram you should practice and review. You're going to have an opportunity to do that as well today. So what I have for you today is I want you to watch the video. The link is in the lesson plan for today, and it's also in task 2, which is pages 11 and 12 in your book. But if you open up the lesson plan, you should just be able to click on the video link and it should take you right there. I really like this video. It's a great overview. So I would suggest watching it a few times, not necessarily all today, but to get that big picture of what's going on in this unit. This has kind of all the main points that we need to highlight. So you're going to watch the video. It's about 8 minutes long, and then you're going to answer the questions on page 11 and 12. And I'll post the answers for that tomorrow. I hope everyone is doing well and staying safe. I miss you, and we'll talk to you soon.